Hello guys, welcome to another video. In this course we will learn about the soil physics and chemistry. Soil physics and chemistry contains these contents such as soil texture, structure, density, particle density, bulk density, soil porosity, soil air temperature, color, water consistency, strength, pH, acidity and alkalinity, buffering capacity, silicate clays, ion exchange, cation exchange and anion exchange, carbon nitrogen ratio, etc. All of these contents are included in this course. That means the part of soil physics and soil chemistry. So let's get started. Firstly, I'd like to tell about the part of the soil physics. Firstly, I would like to tell about the soil texture. So, what is soil texture? Soil texture refers to the relative percentage of sand, silt and clay in a soil. That means in a soil, relative percentage of sand, silt and clay is known as soil texture. The proportion of each size in a given soil cannot be easily altered and it is considered as a basic property of a soil. The soil separates are defined in terms of diameter in millimeters of the particles. Soil particles less than 2 millimeter is called fine earth. Then here we can see the soil textural class. We know that there are mainly three soil textural class: sand, silt and clay. Here we can see in the picture sand, silt and clay, and loam is the mixture of sand, silt, clay. So mainly three classes: sand, silt and clay. Sand includes all soils in which the sand separates make up at least 70% of the material by weight. And then silt includes soils with at least 80% silt and 12% or less than 12% clay. Particle size intermediate between sand and clay. Then clay includes soils with at least 35 to 40% clay separate. So this is the main textural classes of soil. Now we are going to learn about the diameter. Here we can see the diameter such as coarse sand diameter maybe 2 to 0.2 millimeter. Then fine sand diameter may be 0.2 to 0.02 millimeter. Then silt diameter may be 0.02 to 0.002 millimeter. Then clay soil may be diameter may be less than 0.002 millimeter. So this is the diameter of the soil particles. Now I'm going to tell about the sandy soil. Sandy soil made up of withered primary rock minerals. The particles are irregular in outline. They are large and so do not pack together easily. Large pore space in between. That means there are a large pore space in between the sandy soil. Air gets in very easily and water flows rapidly through it because there are large pores. So air can be easily get inside and water can flow rapidly. Got clay stuck on their boots. So this is the concept of sand. Now we are going to learn about the silt. Here we can see the picture of silt soil. So silt particles are smaller than sand. Smaller pore spaces, that means the pore spaces between silty soil are smaller, more difficult to drain. Drainage is difficult. Unlike clay particles, silt does not fluctuate. So this is the concept of silt soil. Now we are going to see the clay soil. Clay soil is very small indeed. Secondary minerals chemically altered by weathering. Chemical weathering such as hydration, hydrolysis, dissolution causes the original mineral matter to degrade into its chemical constituents. mainly silicon, aluminium, iron, magnesium, potassium, and calcium. Once released, they recrystallize to form secondary minerals. Then large surface area, although the pore spaces are teeny. That means the pore space between clay soil is very small or teeny. Negatively charged. Clay soil is, we know that clay soil is negatively charged. Negatively charged, which means they attract positively charged cations. That means clay soil attract positive cations such as calcium, magnesium, hydrogen, aluminium, potassium, etc. Then clay has a capacity for water retention and will expand on being wetted and shrinking on drying. Anyone familiar with clay lands will have been seen deep and wide cracks in grass fields during times of drought and probably. So that's all for this. See you in the next video. Thanks for watching.